Welcome to today's webinar, Why Data is Killing Your AI Project and What to Do About It. My name is Gottfried Seringer. I'm CMO at Lake FS, and I'll be your host today and moderator throughout the webinar. So let me get to the introductions here. As you can see, we have a great panel of experts joining me. Um, they have all worked in AI and data engineering for a long time. John Darrington, welcome to the webinar today. John is a senior lead software engineer at ExoStellar. He was previously principal software architect at Idaho National Lab, and John joins us from Portland, Maine today. Then we have Ion Koutsouris. I hope I pronounced your name properly here, Ion. Um, Ion is a very experienced data and ML engineer, also a data scientist and open source advocate with experience across a range of companies and industries, including Philips, Cognizant, and ASML. And Ion joins us today from Maastricht in the Netherlands. Welcome, both John and Ion, today. And last but not least, we're also joined by my colleague, Ido Avneri, who has over 2 decades of experience with complex software and data projects and has probably talked to more companies about AI and data management as all of us together. And Ido is joining us today from our office in New York City. And again, I'm Gottfried, and I'm dialing in from Boston today. So we are all over the place. Always great to see people from different places. One more quick introduction before we jump in the agenda, just because not everybody in the audience is familiar with Lake FS. Just a little bit of context. At Lake FS, we are on a mission to close the data infrastructure gap that has become this huge bottleneck for many AI initiatives. We are doing this with a highly scalable Git-like data version control solution designed for enterprise use cases. And Lake FS is deployed by data engineering, AI, ML ops, and data science teams across some of the largest companies and government agencies around the world, literally managing petabytes of data. Companies including Amazon, Volvo, Lockheed Martin, and many, many more. You see some of the logos here on the right side of the screen. What do we have in store today? So we'll take a look at the state of enterprise AI for a moment, and then talk about the impact data version control can have on that. We'll look at some real world examples and use cases, and then we'll hear from our expert panel about some of the challenges they tackled and how they've tackled them. And then we'll close it off with just a brief view of Lake FS. We won't bore you with a long commercial today. Just to prevent some or preempt some questions there, how Lake FS is changing the game for enterprise AI, and then we'll have a few minutes left for Q&A at the end, and we'll definitely let you go before the top of the hour. Now let's talk about the state of enterprise AI. Where do things stand? A lot has happened in the last 12 months. World is very different today. And companies and IT teams in those companies, they have gone through many ups and downs throughout this time. Gone through that hype cycle of excitement and then disillusionment, probably more than ever. Maybe even on a daily or weekly basis, always oscillating between all the things you can do and then some of the challenges you hit. So where do we stand? Well, to be honest, it doesn't look so great at the moment, if you believe some of the reports you see out there. You've probably seen many of you have probably seen the MIT report that just dropped a few weeks ago, literally, where that report finds that 95%, let that sink in, 95% of AI pilots are failing. That is indeed a kind of a sobering number, sobering assessment. And there are many, many layers to that, and there are lots of other organizations who are looking at this. So Gartner, for example, the big analyst firm, has also talked about many of those challenges and which challenges might lead to such a failure rate. And one of the biggest challenges they found is that in companies, data is not AI ready. In fact, in their own survey, also a fairly recent survey, they found that 97% of companies feel like that their data is not AI ready. It's not a huge number and huge challenge there. And we found this survey from E&Y, the large global accounting firm here that probably brought this to the point most clearly. They really call out the data infrastructure as a number one roadblock for AI in the enterprise. They say that 83% of the companies they talked to, they surveyed in their particular report here, that AI adoption would be faster if they had a stronger data infrastructure. Again, very different types of surveys and companies and reports and so forth, but they really put together this puzzle piece of why that AI is still struggling in enterprises, particularly. So what's the issue? Um, where do people get stuck? Well, this is sort of a great example. If you look at the AI MLOps lifecycle altogether, starting from data preparation to training to running the model and all the steps in between, you see a big velocity problem. Um, for example, data preparation takes a huge amount of time. If you talk to data practitioner, they probably need 60, 70, 80% of their time to just to get started before you even actually can start talk about AI and the model development and all together. It's about getting the data right. And it's a huge challenge, a lot of manual back and forth involved there. Collaboration is a big issue. How do I make sure that the part of the data I work on, I'm not messing with data from my colleagues? How do I make sure things don't get copied multiple times over, where I lose control, where I lose compliance, where later on don't know where things are? Not even speaking about tremendous amount of storage cost and effort that is involved with that. And then, of course, data quality comes up again and again. Poor data, we all know this, poor data leads to poor models. So those quality issues creep up everywhere, and they usually get discovered late in the process. And of course, the later you discover that, maybe even in the live model, the harder it is to fix it. Quality across all different types of data, not only my source data, but my metadata as well. How do I make sure it's reliable and you don't lose context altogether? Another sort of related issue there is reproducibility. How do I know which specific data set was powering which model? How can I pull exact that same complete data set again if I need to? Which is a frequent thing when it comes to governance. You want to track ownership, you want to track access, you want to make sure there's the right hygiene in your data, and all that. When it's manual, it's holding you up and it's preventing your projects from being successful, and it's probably one of the reasons for the abandonment rate that MIT was talking about. And lastly, the topic I know everybody in this call, I'm sure, loves to talk about. It's compliance, the thing that haunts every team, particularly in regulated industries, but certainly across lots of different types of companies. If you're held back because you asked about certain audit checks and balance that you need to fulfill, maybe you're ready to go live, but to just get that paperwork done and get all those checks done, it's time consuming, complex, error prone. And again, if you don't have an automated way to support that, it's going to be very painful. So with having said all that, let's figure out how can we address all those things, and let's turn to our experts here and first um, ask Ido, what can we do to actually deliver AI projects at the speed and quality we truly need? And how can data version control help us address those roadblocks, Ido?
Yeah, that's a great question, Gottfried. Thanks. I mean, obviously, by the nature of things, we speak with hundreds of companies dealing with data roadblocks in their AI journey, as EY called it. And I think the very first thing you need to do is, if you want smooth sailing, developing compliant models efficiently and quickly, you need to have the right data foundation in place, right? If you have the right data infrastructure, then everyone can do their jobs. And then the more you scale, the more you benefit from that infrastructure. It's the gift that keeps on giving, right? So by enabling data version control, what that means is that first of all, there is a place where everybody can access the data, right? A byproduct of versioning is a single pane of glass and a single pane of a source of truth. That's like your main branch. It also means that if you want to experiment, run pipelines, mess with the data, train models, everything that you want to do can be done in isolation and isolated branches because you have versioning control in place. And typically when we have these conversations with users, this is kind of where some of them have like an aha moment and they say, I can't even imagine developing code without without version control. Why am I doing this for data? Right? So kind of naturally this makes sense to people because when you Gottfried work on the data and I work on my own version of the data, that means that we can compare them, we can track changes, lineage, see who changed what. We can tie the data to the code, to the model, access historical version, troubleshoot. These are all heavy lifting, manual, labor intensive, time consuming tasks if you don't have data version control in place, and are millisecond operations if you do have data version control in place. And I'm not saying that it's exactly Git, right? It's not exactly Git, of course, because there are requirements for data version control at scale that are different. For example, I want to work locally with massive data sets that are sitting somewhere on the cloud, right? And I don't want to copy it over because again, that can accelerate my job, my work, and I don't have to copy data, sample data, do things like that. So there's specific things for different than Git for data version control, but the framework makes sense because versioning does increase quality control, right? When you have the Git actions, every time you promote data, you can run automatic checks. And there are thousands of use cases for that: schema validation, format validation, size of data, specific columns. Every day I learn a new use case for these Git actions to approach. And then the last byproduct, which is very important to mention, is extremely simple governance, right? And it's not only who changed what when, which obviously you get, but every day we speak with companies that the AI regulations are creeping on them, and what the FDA found okay last year is not what the FDA will be okay with next year. And we have folks that need lineage all the way back to the raw data and through transformation through every step of the way. And the data that's actually being used should be stored sometimes for decades, often for years, right? And once again, this is something very difficult to do without versioning and very simple to do with versioning. And I think that is why we really see massive adoption of Lake FS. You've mentioned many of these customers before. We have here three use cases for time. I'm looking at the clock. I'm not going to go into details in each and every one of them. We're fortunate to work in production of some of the largest data lakes in the world. For years now, you can learn more about these ones and others in our website, in press releases in their websites, and things like that. Lockheed Martin's AI factory, they're very proud of it. They have a lot of press around it. It was designed to accelerate development and deployment and scale AI in their defense and aerosystem programs, and to ensure that models are governed with speed, reproducibility, and compliance. And we support that mission by bringing that version control that allows reproducibility to massive data pipelines and enable them with petabyte scale data sets to have auditable, repeatable experiments that help them get ready for production faster. Volvo is another example here that tried to work with a low-scale data version control system and then switch for LakeFS for the infrastructure. ARM is maybe many of you know that it's their very heavily engineering focused company, which led to massive data scale, and without any supervision on top of it, it just went out of control, and it was impossible to track historical data, understand what data is actually important, what is not, what is being used, what is not being used, and they use LakeFS at the infrastructure level to allow a very high performant data infrastructure. This is one of those cases when constantly I heard, I wish I had this earlier. I wish I had this earlier. I think the lesson from this is it's never too early to put the right infrastructure in place. You can only regret putting it too late. And kind of landing this all together, basically, when you do put data version control in place, then you get higher adoption, right? You get higher velocity with without sacrificing quality, and you get compliance as a byproduct as a part of this. So you can really accelerate the time to market, which will increase your competitive edge and obviously reduce your cost, increase your revenue, and hopefully provide much happier customer as a part of this journey.
Well, thank you, though. That's a great overview here and great introduction to a lot of aspects here. But let's go to our experts here who've really experienced a lot of this on the ground. So again, welcoming John and Eon here. Thank you for joining us today. And I was curious about some of your experiences, and maybe to start out with, if maybe I'll ask John first. If you could share a little bit of context about maybe some projects you've worked on, what were sort of some of the initial sort of the key goals about those projects, and what challenges did you have to navigate around them?
Sure. So one of the bigger projects that I worked on, I actually spoke at the Databricks Data and AI Summit back in 2024 on, and it had to do with building basically a full end-to-end data management platform that would allow researchers in the field and like just different laboratories to collaborate, coordinate on data, bring it into a centralized location, and then allow us to build, things like machine learning on top of it. And obviously, I can't go into too many more details, but I do. Our whole goal was to foster collaboration and to do so in a manner where it was cheaper and more efficient for them to collaborate with this system than it would be to try to do things on their own. And you asked a little bit about the initial heartache that we were trying to get away from. I think there's really three things in kind of the government space with regards to data management that we were significant challenges to overcome. That's trash data, so dealing with extra files, not knowing what data is actually important. So there's a lot of curation that has to happen. As part of that curation, we always deal with different kind of like desperate file formats, very bespoke file formats that aren't in like wide use. And then naming schemes that might clash within namespaces if you're not careful. And then finally, the other hurdle a significant challenge to overcome, I guess, would always be permissions management, isolation, and the control of the data, visibility, and access to those individuals that want to work with it across these organizations. So that would I think that answers your questions there, Gottfried.
It does, and I love how quickly sort of you got right to where the rubber meets the road with some very specific details there in terms of what challenges you hit. So definitely sounds like you were right in the middle of that. Ewan, let me ask you the same question. Can you sort of give a little background and some of the issues you've encountered?
Yeah, that actually comes one project to mind. It's one of the projects in my former job. What we wanted to do is essentially was build a model that gave insights into all kind of maintenance related activities of the systems, which meant we actually had to interrupt multiple data sources from different systems. So that could be machine systems, but there could also be operational information, supply chain. So it was a quite variety of data sets and also quite a lot of volume. And the complexity we had at that time was we were working with 6 or 5 people at the same time on a single algorithm, which meant we all had to fine tune small components of that model, which meant if someone upstream changes something, it might have affected downstream the input of my next step. And that was one of the key challenges there. At the beginning, when I joined the team, there wasn't really a way of working on how to do that collaboratively at that scale. So eventually we looked into ways, okay, how can we do proper versioning of our data sets? How can we look at the way we orchestrate our task, modularize our code? So basically split up our whole pipelines in proper sub-steps that can be separately executed. And then if those are separately executed, then you can start off from a later point. Looking at that, we also were looking at different ways of storing data. So initially, we always were saving in Parquet, but we eventually moved to using Delta Lake, for example. So we also looked at how can we optimize the storage format of our lakehouse, and how can we improve the efficiency of our compute runtime, so that we can efficiently work with 6 of us on the same algorithm without making it painful for the other person and stepping on each other's toes, which in the beginning happened quite often. Yeah, that's
Yeah, that's very frustrating. Indeed, I can totally imagine that that takes up not only a lot of time, but also yeah, builds up frustration for sure.
yeah.
Uh, maybe I'll stick with you, Ian, from on the do's and don'ts. So you just sort of hinted maybe to a few, but we have a lot of other like peers of yours listening to this webinar, and I'm sure they'd love to take some learnings from you in terms of like don't do this or do that, or maybe some war stories in terms of that way you learned it the hard way. That might be helpful here.
Yeah. I guess one don't comes to mind is select the tool that's used very common in the industry. Like have a proper look at your use case. What do you need? And what do you want to achieve before just selecting a random tool that's very popular and then slapping it on. That's like one don't. One do, I would say, is create a lot of modular components that you can reuse across your code base. So if there are certain UDFs that you can use in terms of data transformations, and you can see that they're able to be applicable across multiple data sets, try to set up this kind of repo or library that you can use and share across. Yeah, what kind of other things? There are many things.
Okay.
But,
Thank you. Yeah, well, I won't press you on more. Maybe we'll have some time at the end if anything else comes up there. John, do you have any do's and don'ts? Any scars you can share from the past?
Yeah, so I have one that's kind of general and one that kind of gets into the weeds. But the first one I would say is you have to get your permissions and management strategy down prior to opening your tools and opening your environments up to the end users. Because if you don't have a good story for how management is going to happen within LakeFS, if you're using kind of that tool or another tool for versioning, like or just your general compute layers, if you don't have a good story or a good idea of how your permissions are going to work and your management is going to work, and you open the gates, you can't easily close those gates and correct that foundation. And so you're going to be constantly kind of building the train tracks underneath you as you're going, and that's not an ideal situation. The other one is fairly technical, but you definitely need to understand, and maybe not so much, but you need to understand the end user who's actually looking at this data and computing on this data. How are they using this? Are they using this within the terms of an HPC? Are they using cloud compute? Are they using their local machine using something like DuckDB? As soon as you're able to understand the end user, I think you're able to set up the tooling, set up the access patterns that make most sense for your use case. So again, permissions up and running and management, and then figure out the end access pattern of the person actually using the data.
Yeah, yeah, no, absolutely. That really, really good pointers here. Now, one topic that is, oops, sorry, it was one slide too quickly. One topic that is sometimes gets forgotten, even so it's obviously a top level topic, but a lot of times hard to address when in the weeds of building complex infrastructure and projects and so forth. But in the end, doing this for a business reason, right? There's a business reason behind all of those projects we're working on. How have you sort of most effectively communicated the business value that, or at least the goals that you're trying to achieve here to others across the organization that might not be sort of in the middle of your projects? And I'll stick with you, John, first, then we'll go to Eon.
Sure. So I tend to, when I'm talking to stakeholders or the individuals that this is going to impact the most, I tend to use the cluttered desktop analogy. We talk about a lot of executives or people that use desktops every day have a very cluttered desktop. They have files on there, they have shortcuts. And one, I ask them how they feel if somebody sees their desktop, and usually it's embarrassment for one. So they have a vested interest in presenting a unified structure for data and a unified instance there. But then we start talking about, okay, how hard is it actually for you to find things on your desktop? Oh, it's easy. I know where this is at. Okay, but let's imagine now that your desktop is being used by 1,000 people. How hard is it for them to find things? How much faster could they get their work done? How much faster could they understand your problem space? And so as soon as I'm able to kind of get it into into this space of, let's use this analogy to talk about your data structure, I think they start to understand that not only is it looks shiny and nice and ensures that our data is very nice looking, it also drastically increases the speed with which individuals can work with that data. And then you can take that analogy very far and ask about things of like, okay, well, do you want them deleting your files? Do you want them being able to work with them? Do you want them to have access to your entire desktop? And so we start talking about, you have this massive distributed file system. And we want to utilize the cheapest way to manage that and the cheapest way to store that, which is typically object storage now. You need tooling on top of that to provide a more unified experience. And usually once I'm able to help them understand how it would look on a small scale, they're far smarter and more intelligent than me with regards to business value, and they can take it from there. So it's basically, you have to jumpstart them. You have to help them understand the problem space first and why it's important. And then after that, I think they do a lot of the work themselves in figuring out the like any ROI or value that comes after the fact.
I love that analogy, and I wouldn't want anybody to look at my desktop, even so I clean things up before the webinar, at least on the surface to, today. But definitely a good example, also a good example how much time gets lost just trying to dig through everything and try to find stuff and organize stuff just for me. Great analogy. Eon, what do you think? How do you talk about this?
So what generally for me works quite well, and that's either where you're trying to explain the value of an internal change within your team, but whether that's also external. For me, it's most often showing an example of something that's working and showing an actual improvement. and then showing that contrast to that person you're trying to convince. I've used it quite often, also making changes internally in terms of like the whole architecture. I just started doing it, made a proper demo of it, and then showed the actual value of it if we would implement this change and how long it would take to implement it. So giving kind of the pros and benefits of going the current direction that we're already on, or deviating and doing this improvement that might bring many benefits. That's generally my approach.
Awesome. Yeah, I mean, sort of the before and after effect is can be quite powerful.
Yeah.
I totally see that. Um, this is maybe a bit of an open-ended question, but the field of data and AI engineering certainly evolved a ton over the last couple of years. What have you seen of some of the key drivers, and how do you think sort of what comes out of there from now on? Ian, I'll ask you first, since you just had the mic.
Yeah, I'll break it down in the two areas. So in terms of data engineering and the data ecosystem, there's generally a trend where you see of composable data systems that rising up. So you have tools like Iceberg, but also Lakeifest supporting Iceberg catalog. So this whole open world of data systems that can be connected, that's something definitely that's happening, and I think it's a very good trend because it means you can plug in any data component or any system into another system, and it allows you to have way more freedom in the way you would set up your architecture. And what mostly drives that is, open standards like Arrow, certain storage formats like Parquet, all these kind of things together allow you to do those things. In terms of the AI engineering field, it's tough because it's moving so fast, way faster, and there are also so many projects that are popping up, trying to tackle almost the same thing that another project is already tackling. So it's very difficult to keep up. I think eventually we'll come into an area where a lot of these projects they will fall off because they didn't provide the value that they should have provided, and then you will have some of the top products that will stick out. So in terms of AI gateways, there are so many AI gateways at the moment, but in the end, there should be eventually there will just be a couple that will stay over.
Yeah.
There's nothing more to add in terms of AI engineering. It's a very evolving area and field. Let's see where it goes.
Yeah, indeed. I mean, new stuff comes up every day. Probably just in the time we just talked today, there's already something new somewhere. John, what do you think? What are your thoughts on this topic?
Yeah, I have a lot of thoughts, especially with the company that I'm in now, where we focus primarily on efficiency and hardware. Um, I think efficiency and data quality are basically going to become the key players over the next 6 months to 2 years. Efficiency, because now we have a lot of hardware out there. We have a lot of things that we want to do with said hardware, train models, run inference, do all this work, store data. And we have way too much to do with the tools we have. And so we're going to want to use those tools as efficiently as possible. And just as we see kind of in the farming space, where we see small farms being conglomerated into larger farms, we're going to see the same thing happen within the data and AI space, where a lot of these smaller instances are being consumed by big ones. And they're going to want to find ways to do things as efficient as possible. And then on top of that, and kind of plays into that, I think we're going to see a lot of talk around data quality, because there's a lot of garbage data now, especially since we're producing so much more data and producing a lot of garbage data, not to lie here. And so being able to easily understand the quality of the data and control and maintain the quality of the data that you're feeding into your models, the data you're feeding into your reports, the data that you're working with day by day, I think is going to be a key player in the success of any company building itself on top of data.
Yeah, I couldn't agree more there. I mean, it's the garbage in, garbage out. So data quality is absolutely a key foundation, and you can put all the snazzy tools together you want. If you have bad data, you're not going to get good results. So the quality is absolutely key. Well, thank you for this great discussion. We'll get back to a few questions in a few minutes, but I'll just give you a little break for a moment, and we'll get back to Ido. And really want to see how does Lake FS now specifically. We talked sort of more conceptually up till now, but I'm sure the audience has gotten at least a little bit curious here. How does Lake FS help here and change the game for enterprise AI? Ido?
Yeah, I think that first of all, let's talk a little bit about what LakeFS is if we go to the next slide, because I think it's important. Basically, we are an infrastructure solution. We sit on top of the object store, whether that is a cloud object store like S3, Azure Blob Storage, Google Cloud Storage, or on-premise object store like Min.io, Dell ECS, NetApp Storage Grid, Ceph. There's dozens out there. And imagine that you can take a bucket or a collection of buckets and you can give them a Git interface. So you can branch, commit, rollback, and things like that. What that means is that we are completely format agnostic. So we can do this for iceberg tables or Parquet files or images or videos, anything that you need. And the way that it's architected is basically whatever compute you use to access your storage, you will access it through LakeFS without the data actually flowing through LakeFS, and you'll get those versioning capabilities. So it's a very quick integration. Once we have that, if we go to the next slide, then with LakeFS, you can start achieving end-to-end versioning, right? So you can commit every change that happens, right? You can create branches for isolated experiments. All these branches are zero copy clones, so we don't actually copy anything. So you can have 200 petabytes of a lake, and then if John wants to write his own pipeline against this 200 petabyte, then he can create a branch. It's going to take a millisecond, and no additional storage will be cost. So it's really meant for a world of big data, and then as of what we spoke about earlier today, you get the lineage and the compliance out of the box. So every change that I made will be logged under my name. Every change that the service account made will be logged under that service account, right? So we can very easily reproduce the data at every step of the transformation of the data, of every step of every experiment that we're training. Getting full reproducibility, full traceability, full audit and lineage. I see a question in the Q&A also that I'm going to try to read quickly. I'll read it out loud. What are some of the blockers and challenges you've heard from individual data consumers who need to access and work with data inside the large enterprise? What are strategies you're seeing work addressing some of these challenges? Okay, so specifically for accessing data inside large enterprise, I think there is two things here. One of our customers said this is a centralized solution for a distributed problem, right? There's a problem where the data is all over the place, and by nature of bringing all the data into repositories in LakeFS, getting access to data that previously took uh, months, if not weeks, or if not months, and then after you get the access, then you have to copy all the data somewhere else. Then you have to play with it. So that also requires more red tape. Now you immediately get access. I don't have write access. Okay, I'm going to create a branch, and then I can write on my own branch, and I can work very efficiently on my data. So specific on access for data in large enterprises, I think that made a huge difference in LakeFS. Because we're using LakeFS because we have import capabilities which allow you to basically take individual data sets import them into LakeFS, and then you kind of crawl, walk, run. You start working with whatever data sets you want to version and an isolated environment going forward.
All right. Thank you, Ido. This was sort of the planned program before we get to the Q&A session. We did not plan a demo. It was sort of the wrong format for this and not the right time for that. But if you're interested in learning more about LakeFS, please come to our website, lakefs.io. There are places you can request a demo, can speak to an expert. You can even get started yourself by just downloading LakeFS and giving it a shot yourself. So please do if you're interested. And now let's take a look at some of the questions that came in. Ido, you just
Yeah, right.
took a
By the
good one.
way, sorry, I don't know if that question was for me. I answered it on LakeFS. I think it might be very interesting to answer it regardless.
It worked quite well there. So you saved me some work. Thank you very much. But maybe Ian, let me ask you the following. When you first were introduced to let's say data version control, I think one of the problems we see across the board is that most people don't know what they don't know. So the question is, how did you get to data version control in the first place, and how do you get maybe specifically to LakeFS in the end, if you can think that far back?
Yeah, that's a couple years already. So let me think. I was probably looking at solutions of data versioning, not specifically LakeFS at that time, because I didn't know the tool, obviously, before I introduced it. So I was just looking, how can I do data versioning? There was versioning within Delta Lake, like it's a core feature, but it didn't give the exact things we needed in terms of working together as a team on a single data set in that sense. So it was just Googling, and eventually I found that LakeFS had a nice abstraction because it sits on top of your object storage, right? It's not embedded into the Lakehouse format, but it sits one layer higher, which allows you to do way more things that you actually need. So in the end, it was just a matter of just Googling it and then stumbling upon it. But after I played around with it, I was pretty sure this was a tool to use to solve our problems. Yeah.
Good. Well, thank you. And I guess the audience here is already sort of in that process.
Yeah.
They at least know what they don't know, but I think the wider data engineering field and AI engineering field probably still in that place. Now, John, let me ask you this. Obviously, we'll all take Ido's word for it that LakeFS is easy to drop in. How quickly were you able to use LakeFS, if you can sort of think back when you first saw LakeFS, and how did it fit in your environment?
So I think it went very well with regards to adoption. It was very quick and easy to set up. LakeFS helped us every step of the way. And honestly, I think it's very intelligently set up to work on top of object storage. So in a lot of cases, tooling that we had was changing things like host names and a few configuration values. Nothing intense to be able to use that tooling. And then, getting the harder part was obviously in, teaching people about it and teaching people about the system and what it could do for them. But I think even in that regard, it was easier than it could be with a black box, because there's a lot of documentation, there's a lot of information, there's a lot of ways to think about this problem and make it available to the end user. And so I found it, at least from my point of view, as kind of an architect and working with the people implementing it, I didn't hear any horrible things about putting this into place or dealing or working with it. Again, mainly configuration values, working on top of object storage instead of fighting against it. just made it to where it fit like a kind of like a puzzle piece. It was a missing piece of the puzzle that we had that was data management.
Great. Can I quote you on that? That I'm just kidding. It's no need to answer here. Let me ask a question to Ido for a moment. You sort of touched on it before already, but just to maybe double click on that, the no duplication of data. Can you just explain that a little bit more because that's definitely a huge deal.
Yeah, that's super important. It's important not only for the um, scalability of LakeFS, i.e., the ability to work with billions of files, but also for compliance and regulations. Because what happens today in data lakes is I love John's desktop because it's so accurate. Analogy is that basically you open an average data swamp, or sorry, data lake, and you see a bunch of final copy, final, never delete two. There's just like all these manual copies of the files, which is a problem because then GDPR kicks in and the user asks to be forgotten. You need to prove that you actually deleted all the details of this user, which is a massive headache, right? Especially Eon in Europe, and I'm sure handles it even more difficultly than we do here in the stateside. Um, the idea in LakeFS is that every commit in LakeFS is basically a collection of pointers to files that sit on top of your managed bucket. And what that means is that we can take advantage of the fact that object stores are immutable, and then when you create a branch, nothing is actually being copied. We just have another set of pointers to the same files, and then if someone changes those files, then you'll have another commit that points to the files that are a part of that commit, and that's how that tree grows over time with very high deduplication. So we only do copy and write, which in big data environments where the mass, the mass majority, the vast majority of the files are static, and then a smaller subset of the files are added and removed on a regular basis, that's very effective for versioning.
Awesome. Thank you, Ido. And maybe just one last tag on question that's sort of related to what both John and Eon were talking about. If I'm now interested to get started, like what kind of effort should I expect? Like what are my first steps here to experience this?
Sorry, can you repeat that? I was reading the question from Joe.
Yes, yeah. No, it was sort of the question, how do I get started? If I want to start, what implementation effort should I expect? And what journey should I expect there?
Yeah, and I think I'm actually going to tie it to the other question here, which is how LakeFS deals with the connection and import action of all types of data sources, right? So LakeFS works on top of object storages, right? So any data that sits on top of S3, Azure Blob Storage, Google Cloud Storage, or MinIO, Dell ECS, NetApp Storage Grid, that we can work with, and then we're completely format agnostic to that. Importing data is seconds, right? So we can, because of that versioning that I described very, very high level before, where we just point to files, you can import without actually copying anything. And then you'll access the data the same way that you always had, only through a LakeFS interface. So if before you're accessing like a file in a collection in a bucket, you'll access a file in a repository using LakeFS. So the setup itself and the transition, as John mentioned before, it's very straightforward and very quick to get started, both on the code level, changing your code to go with versioning, and on the integration level in terms of importing data into LakeFS when you get started.
Awesome. Well, it looks like we are just about out of time, so I'd like to say thank you, Ido, and thank you to our guests, Ion and John, for participating in today's webinar. A very, very good, interesting points. Thank you and goodbye.